An alpha alcohol like this. E1 will still be E1. E2 will still be E2 because they are eclipsed form. But we'll have a little bit problem with E4 and E3. E4 and E3 will have a little bit problem. Why? Because if we have this, can we switch here? If we have this, we take the second case. NH2 OH. NH2 OH. NH2 OH. Okay, when we have this kind of compound, E1 and E2 are still be eclipsed forms. So the level of energy will remain the same. E1 will be high energy, E2 will be the second, but there will be a change in between E3 and E4. Because of this distance, NH2 and OH, this form is supposed to be the less energy conformations. But we have a particularity here. The particularity is in this kind of form, from 2 and from 6, we'll have what they call hydrogen bonds. Because this hydrogen, because it is a little bit shifted, we call it a left shift. It is just left little bit shift. So the distance is not as high as this distance. So there is a possibility to have hydrogen bomb here. And you know what is hydrogen bomb is organic compound. Hydrogen bomb is organic compound contribute to stabilize many compounds. Can you imagine, for example, boiling temperature of water is 100 degrees Celsius. Boiling temperature of ethanol is 60 to 70 degrees Celsius. How can we explain this? Ethanol is high molecular mass than water. So in organic chemistry, we were supposed to have ethanol with high boiling point. But the boiling point is down compared to water. The only explanation is hydrogen bonds. Just to say that hydrogen bonds contribute to stabilize more and more organic compounds. So this should have been the more stable. Okay? But because of this hydrogen bond, the E4 will be here and the E3 here. Is it okay? Just because of these hydrogen bonds, this will be stabilized than these other forms. Okay? So, in this case, the energy diagram will change. We will have, in this case, 1 will be E1, 60 degree will be always E2, but 100, this form, which form? Sound random. 1, 2, 3. 60 degree will be 2. E4, yes. 60 degree will be E4. 3 will be E2. 4 will be E3. 6 will be E4. This is not 6. This is 5. 5 should be E2. 5 should be E2. 6 should be E4. And 7 should be E1. You will just have to join all the A stream. You can see that because of this hydrogen bond, the form of energy diagram has changed. So every time have different energy diagram with this or this because of the presence of these hydrogen bonds. This n-butyl form, this n-butyl in crown form, this n-butyl crown cannot give us exactly the diagonal angles. Newman said if we take this position, we can represent the n-butyl in a different forms. Newman just said to look at what you see exactly in the plan. Newman also said that the first carbon should be represented by a point, and the second carbon will be represented by just a circle. Okay? This is the first carbon, and this second carbon is this.
Первый углерод должен быть представлен просто в качестве точки по версии Ньюмана, а второй углерод должен быть циклом вокруг этой точки.
And just represent what you are, what is in front of you. When you are here, in this carbon, what are you looking? This CH3 on your head. So in this carbon you have on your head CH3. Okay? Let's say A and B. In your right, when you have this position, in your right you have HA. Isn't it? In your right you have HA, and in your left you have HB. That is okay, the first carbon is finished. On your head, you have CH3, on your right, you have HA, on your left, you have HB.
Вот прямо с этой позиции смотрим. Метильная группа, она как бы над нашей головой.
When you have this position, this is in front of the plant, this is behind the plant.
Водород, он как бы справа от нас, если вот мы находимся там, где вот наши глаза. А водород B, он как бы слева от нас. Вот поэтому так на второй позиции изображено, что справа водород A, а слева водород B.
For these other atoms, you have on your head, in the same position, you have on your head CH3, you have C and D. On your right, you will have HC. And on your left, you will have HD. So this is Cram, and this is Newman. This is Cram, this is Newman. So you can have Newman from Cram representations.
То есть, когда вот мы смотрим дальше с той же позиции, мы также видим водород С, он справа, а D слева, но он отходит не от основного, как первый, а от круга, потому что круг он представляет себе второй углерод, и потом от него отходит. И вот эта репрезентация Ньюмана исходит из репрезентации Крама, потому что он же сделал основу на Крама.
We can take an alpha amino acid like this. We can also have the same Newman forms. Here we have Cram representation, and in the same way we can have Newman. This is the first carbon and this is the second carbon. In the first carbon, in our head, we have OH. In the right, we have this H, and in the left, we have another H. Now, not on our head, but less orientated on our feet, we have NH2. It's not up again, now it's down. This NH2. When we have this position, this is down. So here we have NH2. In our right, we have COH, and in our left, we have this H. This is Cram, this is Newman. So we can have from Cram representation, Newman representation.